Welcome to All This Math. This is Professor Parker. And today we're going to do a lesson that comes from either, I would say, like advanced algebra, late algebra 2, or maybe, well, definitely you'll see it in a pre-calc class. You might see it in some algebra 2 classes, possibly. Forgive me, my collar's a little drunk right now, but I still like this sweatshirt. And respect to Hampton University, historically black college located in Hampton, Virginia. The institution where Booker T. Washington was educated. Of course, Booker T. Washington would then go on to become the first president of Tuskegee University down in Tuskegee, Alabama. And Booker T. Washington heavily influenced Marcus Garvey. Marcus Garvey wanted to meet Booker T. Washington, but he wasn't able to. By the time Garvey had come back to the United States, Booker T. Washington had already made transition and passed away. Also, while Booker T. Washington was at Tuskegee, he also brought on George Washington Carver to be a science professor at Tuskegee and taught many of our people at Tuskegee. Also did a lot of experimentation that we still are benefiting from to this day. And also, Booker T. Washington and also George Washington Carver came up with a plan to have a traveling science, I guess it would be like a traveling science cart or horse and carriage, a traveling science horse and carriage. Carver would go into the rural areas around Tuskegee University and teach science to the local people that weren't enrolled in Tuskegee University. So that's just a great example of people at HBCUs doing positive work on campus and also taking their talents off campus to provide for the community and for the masses. All right. So let's get into this problem. So we're going to talk about something called the remainder theorem today. Today we're talking about the remainder theorem. All right, the remainder theorem. Now, what does the remainder theorem say? Now, before I even get into this, I know a lot of people, if you're watching this video and you don't feel confident in your math skills, you don't feel like you're a strong math student, you'll probably see something like this and be automatically nervous, heart start beating real fast. I want you to as a first step, try to relax. Take a deep breath. Relax. I'm going to show you how to do this. I'm going to show you how to do it. I'm going to make it seem easy. All right, I'm going to make it seem easy because it is. Once somebody shows you how to do it, a lot of us see math as difficult because nobody really showed us how to do it. Like we sat in classrooms where, for whatever reason, circumstances or whatever, people just gave us work and kind of expected us to figure it out on our own. And as a student, I wasn't even really that good with just having to figure it out on my own. I could figure some things out on my own, but a lot of things I couldn't really figure out just on my own. But when somebody showed me how to do it, then I could do problems on my own, and then I could eventually figure out how to do the more complex problems, right? Because somebody showed me in the first place. All right, so I'm gonna show you how to do this. So the remainder theorem, what is the remainder theorem? The remainder theorem basically says that if you have a function, in this case, we got x to the fourth minus 2x to the third minus 9x minus 5, and you divide that function by if you use synthetic division, so there's polynomial long division, which we're not going to do today, but there's also synthetic division, which we are going to do today. There are two main types of division that we use when we deal with polynomials. All right, synthetic division is the more like what most people consider the easier way. I tend to think that polynomial long division is not more difficult; it's just maybe more tedious, right? If you use synthetic division with a value like an x value, right, it'll tell you what the value of the function is going to be if you were to evaluate it at that number. That probably sounded confusing. So let me try to say it again. If I use synthetic division, right, and I take this number right here, right, which is my x value, and I basically divide this function by that number using synthetic division, then whatever remainder I end up with for my quotient is what this function is equal to if I was going to evaluate it at that number. When I say evaluate, that means you take a number, right? In this case, a 3. And wherever you see an x at, you plug it in. Replace this x with a 3, replace this x with a 3, replace this x with a 3. And then I do the math using order of operations, right? Whatever number I end up with is going to be the value of the function when x is 3. Because remember, when we talk about the value of a function, we're talking about a y value, right? Because every point on a curve has an x and y value. Now I'm talking about 2-dimensional, not 3-dimensional, because if we get into 3-dimensional, then it's got 3 coordinates. It's got an x, a y, and a z. But let's say we're talking about 2-dimensional, right? So 2-dimensional, imagine we got a xy plane, right? This is my y-axis, this is my x-axis. So if I had a curve like this, right? If I say, okay, what's the value of the function when x is 3? I go to the x-axis, I say, okay, well, let's say 3 is right here, right? Let's say this was 3. Now, where does this graph cross the x value of 3? Right here. So this is my y value. So this is my y value, x value, y value, x value, y value, x value. Where they meet is the point, right? So it's an infinite number of points like that, right? So if I say, what's the value of the function when x is 3, because x is inside the parentheses. See, x is in the parentheses, x is in the parentheses, x is in the parentheses, x is in the parentheses. So this is your x value, right? The y value is what you get after you plug 3 in wherever you see an x at, and then you do the math, all right? But we're going to do it using synthetic division, right? So let's use synthetic division. Now, I have some videos on this channel that specifically address synthetic division, right? So if you've never seen synthetic division before, this might be a little confusing for you, but that's okay, right? Because a lot of times when you see things for the first time in any level of math, it's going to be confusing. There's nothing wrong with you. You just never seen it before. So of course it's going to be confusing, all right? You got to see it a few times. You got to get some practice in, and then it's like you develop that muscle memory. That muscle memory comes into play, and you're like, oh, okay, I get it now. I see the pattern. I know how to do these problems. I was the same way when I first learned it. All right, so synthetic division. So we want to evaluate this function at f of 3, right? So that means we do this. First, you draw like a big L. Rest in peace to Big L, if you was a Big L fan, right? So we draw a big L, right? You take this x value, you put it outside right here. So this is going to have 2 rows, top row, bottom row, top row, bottom row. You put the 3 across at the top row. You don't have to, I guess, but that's how I learned it, so that's what I do. Then you take the coefficients of each of these terms. Well, this is a constant, so you just take the constant. I mean, you could look at it as a coefficient, but I'm not going to get into all that. Let's just treat it like it's a constant. So the coefficient of x to the 4th is positive 1. There's no number written out here. So you put a 1 right there. The coefficient of this is negative 2. So you put a negative 2 right here. Then the coefficient of this is negative 9. But wait, you got to be careful because your terms should go in decreasing order. 4th power, 3rd power, 1st power. Oh, where's x to the 2nd power? It ain't no x to the 2nd power in this function. So what do I got to do? I can't just skip it. I got to put what's called a placeholder. I got to put a 0 to represent 0 x to the 2nd power. Because in order for synthetic division to work, I got to have every degree, every exponent represented. So see, this 1 represents x to the 4th. This negative 2 represents x to the 3rd. This 0 represents x squared because there is no x squared term. And then we're going to put negative 9 because that's x to the 1st. So negative 9 is going to represent x to the 1st. And then this constant at the end is negative 5. Which we could think, I said I wasn't going to go into this, but we could think of this as negative 5 x to the 0 power. Because x to the 0 power is equivalent to 1. So negative 5 times 1 is just negative 5. So we could look at it like that if you want to. All right. Now, the synthetic division problem is set up now. So now we want to do the synthetic division. So this is how you do synthetic division. You start in the first column right here with the 1. You do 1 plus this, which is nothing, right? So you add vertically, multiply diagonally. Add vertically, multiply diagonally. Add vertically, multiply diagonally. So you do 1 plus nothing, which is 1, and then you multiply diagonally. 3 times 1 is 3. But where do you put the 3? In the bottom of the next column, right here, underneath of the negative 2. Then it's the pattern. You add vertically again. Negative 2 plus 3 is positive 1. Then you're going to multiply again. 3 times 1 is 3. Put it right here. 0 plus 3 is 3. Put it right there. 3 times 3 is 9. Put it right there. Add them up. Negative 9 plus 9 is 0. 3 times 0 is 0. Put it right there. Negative 5 plus 0 is negative 5. This is the remainder. This number in the end is the remainder. The last number is always the remainder. All right? So the remainder theorem says that if we want to evaluate a function, evaluate meaning figure out what the numerical value of that function is when we plug in a certain number, basically. Again, evaluate means to figure out the value of a function, the numerical value of a function when we plug in a certain number. So when I plug in 3, what is this going to be equal to when I replace all the x's with a 3? The remainder theorem says I can use synthetic division and figure that out because this last number, which is the remainder, right, is equal to that value. So basically negative 5 is the answer. All right. Now, traditionally, in an Algebra 1 class, you might have seen this. You might have had like a problem that says evaluate at x equals 3, this expression right here. X to the 4th minus 2x to the 3rd minus 9x minus 5, right? You might have seen that in the Algebra 1 class. And all that means is wherever you see an x at, you're going to replace it with a 3, and then you're going to do the calculations using the order of operations. So watch this. You're going to rewrite the problem basically. It's going to be 3 to the 4th power minus 2 times, and you actually should use parentheses for all of these. So wherever you replace an x at, use parentheses. So we got 3 to the 4th power minus 2 times 3 to the 3rd power minus 9 times 3 again minus 5. So now you got it set up. So now again, you got to use order of operations. That's why it's important for you to know the order of operations and know how to use the order of operations. So 3 to the 4th power, we deal with the exponents first. That's 81. 3 to the 3rd power, 27. So it's going to be minus 2 times 27. And then we got minus 9 times 3, minus 5. Now we do our multiplication. 81 minus negative 2 times 27. Negative 2 times 27 is negative 54. So it's going to be minus 54. And then negative 9 times 3, minus 27. And then minus 5. And then we're going to subtract. 81 minus 54 is 27, right? And then 27 minus 27 is 0. 0 minus 5 is negative 5. So you see, when I evaluate this expression at x equals 3, I get negative 5. But when I use synthetic division and I use this number, this value for x out here, my remainder is negative 5. That's the remainder theorem. That's all it is. It ain't that deep. All it means is if you want to evaluate an expression at a certain value for x, and when we evaluate, what we're doing is we're figuring out what y value matches up with that value for x. So if we was to graph this, this would have a point, one of the billions and billions and billions of points that are on this graph, on this curve, however it might look. One of the points would be 3, negative 5. If you plug in a different value for x, you're going to get a different value for y probably, right? But in order to figure out what the values of y would be, we can use synthetic division. That's the whole point of the remainder theorem. So the remainder theorem is like, listen, if you take this x value, use it in synthetic division, you know, whatever your remainder ends up being, and the remainder, sometimes it could be 0, the remainder could be anything. It's just based on how the numbers match up with each other, right? So whatever the remainder is the value, right? Is the value of y that matches up with this x. Because that's what you're looking for. You're looking for the value of y that matches up with the x. Because in order for there to be a point in a two-dimensional graph, you got to have an x coordinate and a y coordinate. An x coordinate and a y coordinate. You got to have an x and a y. So they give you the x and they tell you to figure out what the y is. Sometimes they give you the y until you figure out what the x is. All right, but if you ever want to figure out, you know what I'm saying? If you're given an x and you want to figure out the y value, you can use synthetic division. That's the whole point of the remainder theorem. So the remainder theorem is just something else. It's another trick. It's like a cheat code, you know, in case you don't want to evaluate the old-fashioned way, or the traditional way, I should say, not old-fashioned, but the traditional method that you might have learned in Algebra 1, you know, you just use remainder theorem. All right? That's about it, but go practice some problems using the remainder theorem, and I'll see you on the next video. Peace.